Let's solve the first question here. This is ether cleavage. Now the first question is, are ethers more reactive or least reactive? Ethers, are they more reactive or
Less
least
reactive.
reactive? That's right. Ethers are less reactive in nature. So in order to make them to react, you have to give a strong acid. What is the reactivity of the acid's nature? HI, HBr followed by HCl. You will always see only HI is very commonly given as a reagent for this ether cleavages because HI is a stronger acid here. HI is a stronger acid compared to its other allo acid parts. Okay, let's go for the ether cleavage here. As I mentioned, if it is a primary alkyl halide, the iodide will attack less number of carbon side. The iodide will attack the less number of carbon side. So here, ma'am, both the sides have only one carbon. So obviously, what will be your answer? CH3I plus CH3OH, where this H attacks here and the I attacks this carbon. All right. Let's look at this example. Again, same compound, concentrated HI. Here, I didn't mention whether it is concentrated HI, whether it is excess. But here, I mentioned it is concentrated HI as well as it is in excess. As usual, step number 1, I'll get methyl iodide plus methanol. Now, since the HI is in excess, again, this methanol will react with this HI, CH3OH plus HI, where HI is nothing but H plus and I minus. This will get protonated by the H plus to give CH3O plus H2. Correct? Now this, once it is moving out, will form your carbonium ion, CH3 plus. Now this I minus will attack it to one more time form CH3I. So in this example, when I am given concentrated HI which is in excess, you will get 2 moles of alkyl iodide. You will get 2 moles of alkyl iodide. Let's go to the next example. CH3 thrice OCH3 in the presence of HI. Now remember, I told you when it is a primary alkyl halide, iodide will attack the less number of carbon. Right? Not primary alkyl halide. Oh, sorry, I mentioned alkyl halide. Primary R group is there, not alkyl. Primary R is there. But here, ma'am, I can see it is an CH3 thrice OCH3, right? So I have OCH3. CH3 thrice is available with me. In this case, what will happen? In the previous case, the mechanism was following SN2 mechanism. But here, the mechanism to be followed is SN1 mechanism. Because there is a possibility of generating a more stable carbonium ion. So therefore, it splits up like this, where it is going to give you plus and OCH3 minus. Now this HI's I minus component will go and attach here and the H plus will attach here. So that I get CCCCI plus CH3OH. Clear till this?
Yes, ma'am.
Now let's take up the last question. CH3, CH3 thrice, there is a C that's missing here. ONA plus CH3Br. What is this reaction called as? What is the name of this reaction?
William ether synthesis.
Correct. It is Williamson ether synthesis. So remember, for Williamson ether synthesis, you can have primary alkyl halide plus an alkoxide in the presence of an alcohol. In this case, I will get a substituted product. There is no doubt about it. But if I'm having secondary alkyl halide plus the same constituency, I will have elimination product as well as substitution products. Both products are possible here. Out of this, elimination product will be the major product. If I have tertiary alkyl halide with the same reagent set, there I will have only elimination product. So in Williams and ether synthesis, I can see here it is a primary alkyl halide. Not even primary, it's just a methyl alkyl halide, isn't it? So my product would be CH3O CCH3 thrice. What if I'm giving you this? What will be a major product?
Elimination.
Elimination, that's right. So I have CCH3 thrice, Br is there, but the elimination is going to happen so that its hydrogen moves out to form an alkene here. Okay? What will be a product?
The ring
Oh,
will open and will form
oh,
like OH, and then I will
that's
attach
right.
to the
That's right.
one
I have
side.
lone pair of electron H plus and I minus attached it so that I form O plus and H. Now the I minus attacks it, the ring opens. So I get OH. Remember, if the same thing was given in excess, again the same reaction continues. So that I form 2 moles of iodide. Understood, Ra? The understood part?
But after
Huh.
that, like once it
Huh.
like both the iodides leave and form the like the ethene.
One, no, 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 no. If they again provide heating, then if zinc is available, zinc in the presence of heating, then only it will happen like that.
Okay,
Not the
ma'am.
reaction stops. All right. So let's continue with aldehydes, ketones, and carboxyl